Welcome to Methodical Math. The goal of this video is to explain to you surface integral of a scalar function in methodical steps as simply as it's possible without going in too deep into theory. So when we're dealing with these kinds of integrals, two integrals in the range of g and d sigma, where g is somehow defined, let's first start to understand what our g means. So this basically describes us a circle with the radius of 1. And since a circle starts at 0 and 2 pi, to fulfill the whole radian, we can write down our theta, which we get from this formula, which you will simply have to memorize. First, let's rewrite the d sigma using our formula. D sigma is equal to r times dr times d theta. And to do that, to know what we're supposed to do next, we need to understand what our r is and what our theta is. So let's go back to our circle. The circle, we're considering all the quadrants of the circle. Why I'm talking quadrants, you'll understand in the next exercises. But basically, to complete a full radian, it goes from 0 to 2 pi. So our theta is going to be described as follows. Our theta is smaller or is greater or equal to 0, or smaller and or equal to 2 pi. And our r is simply described as from 0 to 1. Usually this is all you need. Usually you just put in 0 here whenever you're dealing with some kind of r that's described as greater than some number. You'll start to understand this better once we move on to further exercises. And now that we have our two r's, this is really simple. What we do next, we can rewrite these integrals using these ranges, 0, 0, 2 pi, and 1. Because this is the range of our r and this is the range of our theta, since we're integrating by theta and r. So we have x squared plus y squared times d theta, integrating by sigma. We can rewrite that in terms of polar coordinates, which is what these are and what this is, as the same integrals as before, from 0 to 2 pi and from 0 to 1, of whatever this is, and this is clearly a radius of a circle, and we put it to, and we square it. Just do it. This is how you usually do it, just memorize it, right? So we have our r squared inside these brackets, and now we rewrite the d sigma as this that we get from this formula. Just simply memorize it. But once you solve a few exercises out from this topic, you'll start to understand, you'll start to remember this. So this is multiplied by r, dr, and d theta, which means we'll be integrating by r and theta. Let's start with integration by r first. So we have an integral of 2 pi, 0, 1, 0, r to the power of 3, dr, d theta, which is, let's integrate by r first, 2 pi 0, and that's r to the power 4 divided by 4. From the integral formulas, which I assume you understand since this is an advanced calculus topic. But if you want, I can make a video on that as well. And now that we have this out of the way, let's write the ranges of that, which is 1 and 0, and we still have to integrate by d theta. Simply put in 1 over here and 0 over here. To move on to the next step, we will need to substitute 1 for r minus what we have here, substituting the same thing with 0, or r with 0, which is 0 over 4, and d theta, which gives us which gives us 1 over 4 outside of the integral, 2 pi 0 d theta. Well, this is obviously 0, and this will give us obviously 1 over 4. And since this is a constant, we can just pull it out of the integral. And this is just going to be equal to 2 pi over 4. Why? Because we have 2 pi minus 0 multiplied by 1 over 4. Pretty simple. Let's move on to the next exercise. This one is very similar to the previous one, but we are just adding some extra information given in our G. So what changed about our G is now we have a specific value of x here. Our circle is still going to work the same way basically, but what our x tells us is that we are going to be considering the values on the left side of the circle. How so? You're probably familiar with these axes given here. How there's y and there's x, right? So when is x smaller than 0? Well, over here. So we'll be considering these parts of the circle. If we had something else here, for example a different y, we will be simply considering a different part of the same circle. For example, if y was negative, we'll be considering these parts. If y was positive, we'll be considering these parts. If x was positive, we'll be considering these parts. If x and y are positive, we'll be considering only this quadrant. So, to simplify the value of our theta, I have given you a cheat sheet which you can write down and memorize. It will be very useful in solving these kinds of exercises. And since we're considering only the second and third quadrant, we'll be using these two formulas. Pi over 2 is smaller or equal to theta, and theta is greater or equal to pi. Also, in the third quadrant, pi is smaller or equal to theta, and theta is greater or equal to 3 pi over 2. And since we're considering both quadrants, this whole part, we will simply add these two together. So since they're connected in the pi, the value of our theta is going to be in range of 2 pi and 3 pi over 2, because they're connected with pi, and this is the second quadrant, this is the third quadrant, and they have a common point here, so we'll be simply connecting them. And as for our r, pretty simple, just as in the same way we did it in the last exercise. Our r is going to be between 0 and 4, since 4 is the radius of our circle. So now let's move on to solving these integrals. So let's move on to our integrals. As we have given here, the integrals are going to be limited by 2 pi over 2 and 3 pi over 2, and here is going to be 4 and 0. E x squared plus y squared d sigma. But since this is basically the formula from the circles, well, after we will be moving on to polar coordinates, we will be writing this as r squared. So now we have 3 pi over 2 pi over 2 4 0 and e to the power of r squared. And since our d theta is again described by this formula, r dr d theta, we also multiply it by r and integrate on dr and d theta. Now we do use substitution. You should know it by now since we're on integrals and this is a pretty advanced topic, but if you would like me to explain it, I can make a video, just write in the comment. So let's take our u as r squared. Du would be equal to 2r dr. Therefore r dr will be equal to 1 over du. And now with that, we can continue with our integral. I'm gonna write, I don't want to write this integral yet, so I'll just simplify it and then return to it. So we have e to the power of u times 1 over 2 du. And we can pull out the 1 over 2. So we have 1 over 2 integral in ranges from 0 to 4 of e to the power of u du. And that's simply equal to 1 over 2 times e to the power of u in ranges from 4 to 0, which is then equal to 1 over 2 times we substitute the 4 for u and 0 for u, so e to the power of 4 minus e to the power of 0, meaning 1, so we have 1 over 2 times e to the power of 4 minus 1. And let's go back to our d theta. So now we have the integral. Since this is a constant value, we can just pull it out of the integral and get 1 over 2 times e to the power of 4 minus 1 times 3 pi over 2 and 2 over pi over 2 in the integral of d theta, which is 1 over 2 e to the power of 4 e tesseract, if you want to sound smart, times 3 pi over 2 minus pi over 2, which is then equal to, is gonna simplify to 2 pi over 2, meaning just pi. So we have pi times this, meaning pi over 2. This is a simple calculation. E to the power of 4 minus 1. Pretty simple. Let's move on to something more difficult. Now this is something similar to what we did earlier as well. By the way, if you want me to cover more difficult exercises, just simply let me know in the comments. So again, the radius of the circle is going to be 1. And as I said earlier, y is greater than 0, so we'll be talking about the first and second quadrant described with these. So just as we did earlier, we can combine the first and second quadrant since they share these two values, and we're talking about the whole thing. So our theta in this case is going to be described as follows. In between 0 and pi, and our r is going to be described as follows as well, from 0 to 1. Now let's move on to integrating. This is going to be pi, and this is going to be 0, this is going to be 1, this is going to be 0. And now we have e to the power of x squared plus y squared d sigma. So let's rewrite d sigma using our formula I mentioned we've used it earlier. I think you should have it memorized by now, or I'm just gonna use it. Pi 0, 1, 0, e to the power of r squared, meaning I'm just gonna write it down as r times r d theta. So let's isolate our integrals and solve them one by one. R e to the power of r dr. And now we're going to be using the formula I've written here, integration by parts. So let's start integrating by parts. In this case, our u is going to be equal to r. Well, since this isn't a video on integration by parts per se, again, if you want me to cover integration by parts, just simply write it in the comments if you don't understand what's going on here. And so u is going to be equal to r, and our dv, since we're trying to use this formula, is going to be equal, in this case, er dr. Then our du is going to be equal to our dr. Our v is going to be equal to er. Let me fix the r's so they are more clear. So now we just feed this formula. So now we are giving this, let's just feed the formula our data, and we'll be given r times e to the power of r minus the integral er dr, which is then simply equal to r er minus er. And now that we have this, let's write this, let's evaluate it by in terms of 1 and 0, which is e, we substitute ones for r's, minus e, minus, now we substitute zeros for r's, 0 minus 1, which is equal to minus 1. Now that we have this, let's move back to our, let's call it pi integral, which is pi 2. And since this is a constant, I'll just write the minus here. This is minus 1. We can pull it out of the integral. Pi, the integral, it ranges from 0 to pi of the theta, which is pi minus 0, which is minus 1, times pi minus 0, which is minus pi. That's it. Thank you for watching. If you want me to cover more difficult exercises, I'll be happy to do so as well. And if you struggle with any topic in particular and want me to teach you, I also do private tutoring in the ranges of primary school all the way to university level. And let me know in the comments what videos I should do next. Thank you for watching. I hope I helped.